Hey everyone, welcome to my channel. So this is the second lecture of Open RAN. Okay, so far we have already seen the distributed RAN, centralized RAN. Okay, and there is another option to deploy your centralized RAN or cloud RAN. We have already seen this option, right? This is known as option 1. Okay, where the BBUs are centralized at a location. Okay, means instead of installing BBU at each and every cell sites, now BBU has been centralized at a particular location. So this is your option 1. Okay, now there is another option, we call it option 2. Okay, to deploy this centralized RAN or cloud RAN, you can say. Okay, so let me tell you that option. So this is our base station. Okay, let's call it base station 1, and this is our base station 2. Okay, so this is base station 2. So it's RRU of base station 1, and this is the RRU of base station 2. Okay, so what's going to happen here, we are going to split the BBU. So just because of that, we also call it split BBU option. Split BBU. Okay, so we are going to split BBU in two entities, which are known as DU, known as distributed unit, and CU, which is known as centralized unit. This is DU, this is CU. Okay, and this is your core network. Okay, so this is your, okay, so in previous option, this entity was BBU. So we have split this entity in two entities known as DU and CU. Okay, and with this split, we have introduced a new interface known as Midhaul. Okay, we can denote it with MH. This is your Fronthaul, FH. This is your Fronthaul, FH. This is your CPRI cable. This is your CPRI cable. Okay, and this is your backhaul. Okay, so this is the option 2. Okay, and remember, means in this DRAN and CRAN, all the entities like your RRU, DU, CU, means operator has to buy all these entities from same vendor. Means if you are buying RRU of Nokia, you cannot buy the DU of Ericsson. Your DU and CU must, means operator must have to buy these DU and CU from same vendor. Okay, means if your RRU is from Nokia, your DU and CU must also from Nokia. Okay, means same vendor is serving the operator. Okay, now let's start with virtual RAN, which is also known as vRAN. Okay, so before starting vRAN, let me give you a quick review of virtualization. Okay, so let's consider an LT network. This is our UE. Okay, this is our E node P. This is our MME. Okay, this is our SGW, PGW, and here a PCRF will also be there. Okay, so this is a traditional architecture of LTE. Okay, So what happens here means we have a dedicated hardware for each and every entity, like uh, we also known as those hardware are also known as purpose built hardware. Okay, purpose built hardware means their purpose means they can they have a particular purpose, means like E node B will talk to UE only, okay, and provide the messages to core network, okay, and MME is responsible for signaling only, okay. So dedicated hardware will be there for MME. Similarly, SGW take cares of user plane data, okay. So there is a dedicated hardware for SGW also. In similar way, PGW will have its own dedicated hardware, and PCRF will also have its own dedicated hardware, dedicated or purpose built hardware. So you can see each of these entities have a dedicated hardware, okay. Now with the help of virtualization, what has been done, instead of having dedicated hardware, let's say we are going to let me tell you the definition first. What virtualization does: virtualization decouples software from hardware. Okay, let me explain you. Like, means in traditional traditional architecture, let's consider this SGW. We have a dedicated hardware here, right, for SGW. Now what we can do, instead of having dedicated hardware, an operator can buy a x86 server, okay, x86 server, and which is also known as COTS server. COTS stands for commercial of the self, okay, COTS server, okay, means vendors like Dell and HP make these, means they are the manufacturer of these kind of server, okay. Actually these servers have compute and your storage and your network, okay. Compute like means they are very strong server actually. So compute, you can say they have, means it can have multiple CPUs, okay, like it can have 8 CPUs, or RAM will be higher, okay, and the storage is also quite huge, and a network like routers and switches, or NIC you can say, okay. Means in simple words, these servers are very strong, okay, and have huge memory, huge, means multiple CPUs will be there, okay. So these, instead of buying dedicated hardware, this COTS server is installed at means instead of installing this dedicated hardware, COTS hardware is installed, and over on that COTS hardware a hypervisor is installed. Okay, hypervisor installed, and on hypervisor guest OS is installed. Okay, So let's so VRAN means we have to draw the same diagram as we have drawn for centralized RAN. So this is our base station 1, this is our base station 2. Okay, VRAN also have two options. So first we will see the option 1. Okay, so this base station will have its RRU. Okay, and this RRU will be connected to your BBU in pool, you can say. Again, this is the RRU of base station 2. We have connected it to BBU pool, and this BBU pool is connected to core network. Okay, so this is your CPRI. This is CPRI of base station 2, and this is your Fronthaul. This is Fronthaul, and this is Backhaul. So this is the same option 1 that we have seen in centralized RAN or cloud RAN. Okay, now the virtualization is installed in BBU. Okay, virtualization. Okay, so in previous architecture of ORAN, we have a dedicated we have dedicated hardware for BBUs. Okay, now what we'll do, we will take a x86 server, or you can say we will have a COT server, and over to that COT server we will install hypervisor. And on that hypervisor we will install guest OS, guest OS 1, guest OS 2, you can say. And on those guest OS we will install virtual machines, and in that virtual machine we are going to install an application that will act like BBU. Okay, so we remove the dedicated hardware and we install this x86 server. So this is how virtualization is introduced in centralized RAN or cloud RAN. Okay, in similar way, option 2 is there. Okay, we know that option 2 where we split the BBU, right? We splitted the BBU in two entities, DU and CU. Let me draw the diagram. This is our base station 1. This is our base station 2. And this is the RRU of base station 1. This is RRU of base station 2. Now we are going to split the BBU in two entities. First entity is known as DU, that is your distributed unit. The other entity is known as CU, that is your centralized unit. And this is further connected to your core network. Okay, fine. Let's draw the connections. Okay, let me mention the names of interfaces. This is your CPRI. This is CPRI. This is your Fronthaul. Fronthaul is the connection between RRU and DU, and this is your Midhaul, and this is your Backhaul. Guys, just for your information, this RRU, what it will do, it will convert the radio signals. Actually, it is connected between antenna and DU. Okay, so it will convert the radio signals into the signals which can be understood by this DU. Okay, so you can say we have splitted the BBU here. BBU is splitted in two entities, DU and CU. Okay, now we are going to institute virtualization at two entities at DU. So now this DU will be known as VDU, you can say, and at this CU, VCU, that is virtualized CU. So virtualization has been introduced at DU and CU. Okay, so what will happen? We will remove the dedicated hardware. Let's say this is the dedicated hardware of DU and this is the dedicated hardware of CU. Okay, so we will remove these dedicated hardwares, and what we will do, we will install a COT server or x86 server. We also call it generic server. We will install the hypervisor. And on hypervisor we will install guest OS. Okay, guest OS. And on that guest OS we will install VMs. And on that VM we will install application. Let's say this application 1 will act like DU and this application 2 will behave like CU. Okay, so you can see we replace the dedicated hardware with this powerful x86 server. Okay, this is the virtualization. Okay, so we have introduced the virtualization in our traditional RAN, you can say cloud RAN or centralized RAN. Okay, now let's move to Open RAN. Okay, so Open RAN takes vRAN to next level. Okay, so what in Open RAN, what exactly has been done? Let me tell you. Yeah. Okay, so the interfaces between the RRU, I'm not going to make a new diagram because it's similar to what we have seen in virtual RAN. Okay, so in Open RAN, the interfaces between RRU and DU has become open. Okay, similarly, interface between DU and CU also become open. Open means now operator have flexibility to merge the hardwares from different vendors. Okay, so as we know, our base station now our base station consists of RRU plus DU plus CU. Okay, these are the components of our base station. Okay, so in virtual RAN there is restriction on operator, right? If you're buying RRU from Nokia, you have to buy the DU and CU also from Nokia. Means you cannot buy DU and CU from Ericsson if you are using RRU of Nokia. Okay, means operator has to buy all these three hardwares from same vendor. Now with the introduction of Open RAN, operator has the flexibility to merge the hardwares from different vendors. Like RRU you can buy from Nokia. Okay, DU you can buy from Ericsson or from Airspan. Okay, and there is another vendor, Sercom. Okay, and CU you can buy from Huawei. Okay, so this is possible with the introduction of Open RAN only, that we can merge the hardwares from different vendors. Okay, rest of the things are same, means whatever we have seen in vRAN, everything is same except that we can merge the different hardwares from different vendors. Okay guys, so this is all about Open RAN. I hope you like the video. Okay, thanks for watching.